Hello everyone. In the video today we will discuss a basic review of chemistry, and if you have not taken chemistry before, do not fret. It is just an introductory overview of some of the basic things you learn in the first few months of chemistry and how they relate to physics. So the first thing we need to talk about are atoms. An atom is the smallest building block of matter. So atom actually comes from atomos, the word for in Latin for undividable. It's either Latin or Latin. So think about cutting an apple in half, and then in half again, and then in half again, until you can't cut it anymore, until it's indivisible. Then you will get an atom. That's where the basic idea comes from. And an atom is composed of elementary particles. And I'm sure you've heard these before. We have neutrons, protons, and electrons. Protons have a positive charge, while electrons have a negative charge. And neutrons have no charge. That's why we call them neutrons, like they're neutral. And protons and neutrons are located in the nucleus and are much heavier than electrons. They're about 2,000 times heavier than electrons. So over here we have the Bohr model of the atom. The nucleus has a bunch of protons and neutrons inside, and the electrons are spinning around crazy on the outside. And it's not exactly how this works in reality, but it's a very good model and it helps us explain a lot of phenomena. Quick note on charges. Here we'd have a proton, here's an electron. Like charges repel each other. So if you have two positive charges, they don't like to be near each other. They will go opposite directions. If you have two negative charges, they also will repel each other. But different charges, if you have a positive and negative, they will attract each other. So, for example, if you have a positive and a negative, they will come together. And we can draw an electric field around any charge. Any charge that exists has an electric field either going out from it, if it's a positive charge, or going into it as a negative charge. And this is how we write it. Electric field lines are drawn from positive charges to negative charges. And we're going to talk more on this later. And click this link. I don't actually know if you can click it from the video, but I'll provide a link on Google Classroom as well. It's a really, really nice simulation. You get to put the positive and negative charges and see how the electric field acts around them. Elements. I'm sure you've all heard of the periodic table of elements. Here it is in all its glory. It is a beautiful way of organizing all of the known elements in one easy-to-read table. And if you take chemistry, then you'll definitely learn all the different ways you can read this table. So let's define an element. An element is a substance whose atoms all have the same number of protons. So the definition of what an element would be by the number of protons. So for example, one hydrogen has one proton. It is the simplest element. It has one proton with one electron. And here is a quick little drawing. You have the proton in the center and an electron going around the outside. Lithium, for example, has 3 protons. So when we look on the periodic table, it's there with number 3, the atomic number. And this happens to have 4 neutrons and 3 electrons. And most elements start with the same number of electrons and protons, making them altogether neutral. So this is neutral because there's one positive, one proton, and one negative electron. So those charges would balance out. So the whole atom, the whole element of hydrogen is neutral. Same thing with lithium. There's 3 positive charges, 3 protons, and 3 negative charges. So the net charge is 0. It is a neutral lithium atom. You might have heard lithium ion, like lithium ion battery. And that's because usually this is happy to give away its 1 electron. And when it gives away its an electron, it will become what's called an ion. We're going to talk about that a little bit in more detail in the next slide. Okay, so remember before we saw the Bohr model, these two examples are also examples of the Bohr model, where you have the nucleus and the atoms going in circles around the outside. In reality, they orbit in these kind of weird, funky shapes that you can see. These are all the different types of orbitals that electrons can exist in. You don't really need to know this, but I want to expose you to like the models we have, the simple models that work really well, and the more complex models that are really hard to use right now, but when you study for math further, they become nice and easy to apply, and they're more realistic to what's actually going on. Orbitals in shells. Orbitals are the clouds in which electrons are most likely to be found. And we say cloud because the electrons are moving so quickly, it's really hard to pinpoint where they are. So it's more like a probability that the electron exists at this space, at this point. And electrons land in different shells based on their energy. So up to 2 electrons can fit in the first shell. We can see it here. Up to 8 electrons can fit in the next shell. The next one is pretty big with, I think, 18. But then the one after that would be 8. And the model to the right, we've said it before, it's the Bohr model. Niels Bohr was a scientist. And although it's not as accurate as to how the electrons actually move, it is accepted due to its usefulness, and especially with what we need to do with it in physics. So the most important property of atoms that you will learn here and that you will learn in your chemistry class is that atoms like to be stable. Just like you, atoms don't like to do a lot of work. And atoms will do anything they can to reach lower energy levels. This means that their outermost shell is full. They have a full number of electrons, they have no extra ones, and they don't need any more to fill it up. So for copper to have a full outer shell, copper can either gain 7 electrons to give it a full outer shell of 8 electrons, or it can just lose this one right there. So think, which is easier? Is it easier to gain 7 electrons or to lose just one of them? And the intuitive answer is losing one. If we get rid of that electron, copper is now stable. It has a full outer shell. And when this happens, it makes a copper atom altogether positively charged. We lost an electron, but we started with the same number of protons, which are positive, and electrons, which are negative, but then we lost one of the negative charges. So when that negative charge goes away, there's an imbalance in charges, and now we have one more positive charge than negative charge. And when an element takes on a positive or negative charge, we call them ions. So copper is very happy to give its outermost electron away, and this is why we use copper in wires. Because copper is so easy to get electrons from, we use them in wires because electricity is all about moving electrons, taking them away from atoms and moving them around. There are other atoms that are even easier to take their electrons from. For example, silver is more conductive of electricity than copper, but as you can imagine, silver is much more expensive than copper. Copper is very abundant, which is one of the reasons why we use it instead of silver. When you have very expensive electronics, they might use silver or even gold because they are more conductive. But for your everyday appliances, we use copper because it is both conductive, it does a very good job conducting, and it's cheap. Electricity and current. So we define current as moving electrons. As long as those electrons are moving, we have current. And current is what gives power to your electrical devices. You know, you plug in your phone, you're getting electricity from the outlet, which is moving current into your devices. A material that allows flows of electrons is called a conductor. And metals make great conductors because they are happy to give away their valence electron. And this fancy word valence just means the outermost, yeah. So the valence shell is the outermost shell. Their valence electrons are all the electrons in the outermost shell. So now imagine a copper wire which has trillions of copper atoms and therefore trillions of electrons ready to flow. On the reverse side of this, a material that does not allow easy flow of electrons is called an insulator. So wood is an insulator, but still dangerous to run high voltage across, and we will see videos of that in another video, or maybe in class. And rubber and plastic are also good insulators, which is why we use them for covering wires. If you look at a wire, it's going to be covered in either rubber or plastic because then you have a much lower risk of getting shocked. You're not going to get shocked because the rubber does not conduct electricity like the inside of the wire does. All right, let's talk about voltage and potential difference. So, all right, we have trillions of electrons, but they're moving all over the place. Think of when the bell rings third period and you're all going to different classes. It's kind of hard to move around the hallway sometimes because all the students are going in every which direction trying to get to their next class. But what if we put a whole bunch of positive charges at one end of the wire and a whole bunch of negative charges at the other end? So in the classroom example, this would be like going from fourth period to fifth period because you have lunch fifth period and then everyone is going to the same place. That means it should be, in theory, easier to move through the hallways. Everyone is going in the same direction instead of randomly all over the place. And that's exactly what will happen in a wire when we put positive charges on one side and negative charges on the other. And that is exactly what a battery does. And here's my very nice picture. We have a whole bunch of positive charges, a whole bunch of negative charges, and these negative charges will be pushed away by the negatives, their other negative friends, and attracted to the positives. And that's how we get a nice current. Yep, electrons are repelled by the negative charges. Remember, like charges repel, and attracted to the positive charges. Different charges attract. And when you have this difference in positive and negative charges, we call it a potential difference. And batteries provide what's called a potential difference, but it's also called a voltage. So you've probably seen danger signs that say high voltage, means there's a very high potential difference. They have stored many types of positive charges or many types of negative charges. And another definition for voltage is the electrical energy given per charge. So kind of like potential energy is the energy per mass, or like how high you lift it depends on the potential energy will depend on both the weight of the object and its height. The same thing goes for potential. And charge in electricity is kind of like mass is for mechanics. And here is our equation that shows the definition of voltage as the energy. Remember, work is energy per charge. Alright, let's summarize what we got so far. Atoms are made of electrons, which are negative, protons, which are positive, and neutrons, which have a neutral charge. Same charges repel, while different charges attract. Electric field lines go out of positive charges and into negative charges. Elements are identified by the number of protons they have. Atoms like to be stable, which means low energy. And a common example we use in physics is copper, and copper will lose an electron, which is nice for wires. Atoms that have a net positive or negative charge are called ions. Materials that give up their electrons easily are called conductors. Those that don't are called insulators. Batteries provide a potential difference, also known as voltage, which moves the electrons all in one direction, which is a current. When electrons are moving, we have a current.